The outer solar system looks calm. For the same reason, a battlefield can look untouched from high above. Distance smooths the damage. From far away, everything beyond Neptune seems cold, dark, and settled. A thin scattering of icy worlds drifting at the edge of the sun's reach. Too remote to feel urgent, too slow to seem alive. But the violence is over, which is why the place looks still. The stillness is late. And the moment you look closely at the orbits, it begins to fail. Bodies are locked into strange ratios. Whole populations lean, stretch, and cross space in ways that should not happen by accident. Some seem trapped. Some look displaced. Some were flung so far outward that they barely remain tied to the sun at all. What survives beyond Neptune is not a quiet border where the solar system simply fades away. It is preserved aftermath, a frozen structure that still carries the geometry of an old disruption.
Before we begin, if you're new here, please consider subscribing to our channel. We'd love to have you in our subscribers community, and your support helps this channel grow.
The familiar picture is easy to understand. 4 giant planets occupy the outer reaches of the planetary system. Beyond the last of them lies Pluto, then a sparse halo of leftovers, a dim frontier of ice and rock. In that version, the architecture feels complete. The planets formed, the debris remained, and the rest is just distance. It is a clean mental image, and for a long time it was close to all we had. The outer dark hid detail. Even Pluto, once treated as a lone outpost, seemed to mark the end of the organized system. That old image was powerful because it matched intuition. The farther from the sun you go, the slower everything becomes. Sunlight weakens, surfaces freeze, orbital periods stretch into centuries. It is easy to assume that the remote edge of the system must also be the least eventful part of it, a place where formations simply trailed off and left a few icy scraps behind. But remoteness is not the same as gentleness. In orbital mechanics, a region can look empty and still preserve violent history with extraordinary precision.
If the inner planets wear their history on battered surfaces, the outer system wears its history in the shapes of orbits. Then the Kuiper Belt began to emerge, not as a neat ring of forgotten fragments, but as a structured region with internal populations, boundaries, clusters, and absences. It became clear that these distant objects were not sprinkled randomly beyond Neptune. Their orbits came in recognizable families. Some stayed in relatively stable, more circular paths. Others were tilted or elongated. Some were locked into repeating gravitational relationships with Neptune. Farther out, another population occupied stretched, unstable paths that carried them away from the main belt into a much broader realm, now called the scattered disk. The outer solar system had not preserved a quiet debris field. It had preserved a sorting pattern. That sorting pattern is where the calm begins to collapse. If the Kuiper Belt were simply a distant reservoir left mostly untouched since formation, its bodies should not be organized the way they are.
You would expect a broad spread of orbits, yes, but not these specific concentrations, not these sharp, resonant groupings, not this clear distinction between populations that appear dynamically cold and those that look stirred, lifted, and rearranged. The belt does not resemble untouched leftovers. It resembles material that interacted with something powerful enough to move bodies into new orbital niches, while also removing much of what had once been there. Pluto is one of the clearest clues. Its orbit crosses Neptune's orbital distance in a broad geometric sense, yet the two worlds never collide. That sounds like a contradiction until you see the pattern underneath it. Pluto is in a 3-2 resonance with Neptune. For every 3 orbits Neptune completes, Pluto completes 2. That repeating timing keeps their positions coordinated. Pluto can cross the radial distance of Neptune's orbit without ever arriving at the same place at the same time. It is not wandering recklessly through danger. It is locked into a gravitational rhythm. On its own, one resonance might sound like a curiosity, but Pluto is not alone, and once you have a population, the excuse of coincidence disappears. The Kuiper belt contains many resonant bodies, and the 3-2 group is prominent enough to have its own name, the Plutinos. Other resonances are populated too. These are not decorative details. They are dynamical fossils. A resonance can shelter an orbit, but it can also act like a moving net. If Neptune changed position over time, its resonances would have shifted with it, sweeping through the outer disk. Bodies encountered by those migrating resonances could be captured, carried, and released into new orbital states. The existence of large resonant populations strongly suggests that Neptune did not simply form where it is and stay there. Neptune moved outward. That idea changed the interpretation of the entire region. Neptune's outward migration provides a mechanism for turning a more ordinary primordial disk into the complex architecture we see now. As Neptune drifted away from the Sun, its gravity disturbed the disk beyond it. Some bodies were trapped into resonances and transported outward. Some were ejected completely, lost to interstellar space, or redirected toward reservoirs even farther out. A calm final picture could emerge from a violent process, because the violence ended long ago, and only its orbital consequences remained. The resonant populations make that reconstruction especially persuasive because they are so specific. Pluto's 3-2 resonance is not just stable, it looks like the outcome of capture during migration. The same is true more broadly for other resonant Kuiper belt objects. Their very existence implies that Neptune's gravitational influence once swept across a denser disk of icy bodies and reorganized part of it into repeating orbital natios. This is one reason the outer solar system is such a valuable archive. Rocks can be altered, surfaces can darken, collisions can erase local detail, but orbital distributions preserve memory in a different way. They keep a record of what kinds of gravitational events were able to happen. The distinction between the cold and hot classical populations deepens that picture. Some Kuiper belt objects retain relatively modest eccentricities and inclinations, as though they escaped the harshest reshaping. Others occupy more excited paths, lifted away from the calm geometry you would expect from a quiet primordial disk. That contrast suggests selective processing rather than uniform disturbance. Neptune's migration could stir some regions strongly while leaving others comparatively sheltered. Any convincing reconstruction has to explain not only disruption, but uneven disruption, why some bodies look dynamically heated while others seem like cautious survivors from an older arrangement. Then there is the scattered disk, which looks less like clean capture and more like the loose debris of repeated close encounters. These objects follow highly elongated, often highly inclined orbits. Some dive back inward toward Neptune's realm before racing hundreds of astronomical units away. They are not a tidy extension of the Kuiper belt. They are a population that has been dynamically thrown outward. Their present-day behavior still reflects that instability. Many are not permanently safe.
They remain part of an evolving exchange between the trans-Neptunian region, the centaurs, and eventually the short-period comets that move deeper into the planetary system. That scattered population is difficult to explain with a quiet, stationary Neptune. It makes far more sense if Neptune once interacted strongly with a massive outer disk while changing its own orbit. A migrating planet can scatter bodies inward and outward, and repeated encounters can leave behind exactly the kind of broad, excited distribution we observe. Some objects were implanted into long-term resonances. Others became part of the dynamically hot classical population.
Others were sent into the scattered disk. The outer solar system was not shaped by one single outcome. It was partitioned, trapped, stirred, displaced, and removed. Even the bodies that share a planet's orbit offer clues. Trojan populations occupy gravitationally stable regions, leading and trailing a planet. Jupiter's Trojans are the famous example, but Neptune has Trojans too, and they are important because they may preserve evidence of migration and capture. Their orbital properties are difficult to reconcile with a picture in which everything formed gently in place and remained undisturbed. Instead, they fit more naturally into a solar system where planetary motion, resonance crossings, and transient instability allowed small bodies to be trapped into co-orbital niches during a larger reshuffling. Trojans are not just companions, they are witnesses.
Once you combine resonant Kuiper belt objects, scattered disk bodies, hot and cold populations, and Trojans, the outer solar system stops looking like a passive edge and starts looking like the surviving edge of an old rearrangement. The giant planets themselves become part of that reconstruction. Their current arrangement appears stable now, but it may not reflect where they began. The leading models of early solar system evolution suggest that the giant planets once occupied a more compact configuration. Beyond them lay a massive planetesimal disk. Over time, countless gravitational encounters exchanged angular momentum between planets and small bodies. The planets migrated, the disk was depleted, the architecture changed. This is the broader framework behind the Nice model, named after the city in France where it was developed. It is not a legend about what certainly happened in perfect detail. It is a reconstruction, an attempt to explain several otherwise disconnected features with one dynamical sequence.
In this framework, the giant planets begin closer together than they are today. Interactions with the surrounding disk gradually alter their orbits. At some stage, a planetary instability occurs. Uranus and Neptune are scattered outward into the trans-Neptunian disk. The disk itself is violently disturbed. Large numbers of small icy bodies are thrown inward, outward, trapped into resonances, or lost. In many versions of that reconstruction, Jupiter and Saturn play a crucial triggering role. As their orbital relationship shifts, the balance of the outer system changes. Uranus and Neptune can then be displaced into the planetesimal disk, where encounters with countless smaller bodies drive further migration and scattering. That kind of instability does not mean planets flew randomly forever. It means there was an interval when the old arrangement broke. The planets shifted into new trajectories, and the disk absorbed the consequences. Afterward, the system settled into a more durable configuration, but not before rewriting the outer architecture on a massive scale.
The power of that framework is not that every simulation produces the same exact solar system. They do not. The power is that migration and instability can reproduce the broad kinds of signatures we actually observe. Neptune's role in structuring the Kuiper belt, resonant capture, the existence of excited populations, the scattering of bodies into distant elongated orbits, and the capture of Trojan populations during planetary rearrangement. The model is useful not because it supplies a dramatic tale, but because the outer solar system looks as though something like this had to occur. The present arrangement is easier to understand as an outcome than as a starting condition. That does not mean every detail is settled. There are still debates over timing, pace, and exact pathways. Neptune's migration may not have been perfectly smooth. Some versions of the reconstruction suggest phases of abrupt movement, sometimes described as a jumping Neptune, which can help explain why certain delicate populations survived while others were implanted elsewhere.
The cold classical Kuiper belt, with its relatively gentle orbits, is especially important here. It appears to preserve a population that was much less disturbed than the hotter, more dynamically excited objects around it. Any successful reconstruction has to account for both violence and survival. How the system was heavily rearranged without erasing every fragile remnant of its earlier state. That balance is one of the strongest reasons astronomers treat the outer solar system as evidence rather than scenery. It contains signs of transport and signs of preservation at the same time. The cold classical objects appear close to primordial in comparison with more disturbed populations. The resonant bodies point toward migration. The scattered disk points toward close gravitational encounters and long-term dynamical leakage. Trojans point toward capture during planetary rearrangement. Together, they do not tell us that every object shared the same fate. They tell us the opposite. The outer disk was processed unevenly.
Some material remained nearly in place. Some was lifted into resonances. And that unevenness is exactly what makes the region so revealing. A single clean sweep would have erased nuance. Instead, the outer solar system records a hierarchy of outcomes. Bodies nearest Neptune's migrating influence were heavily disturbed. Others were caught in resonant migration. Others occupied zones that remained comparatively sheltered. Still others entered unstable channels that fed material inward or cast it far beyond the classical belt. The pattern is too organized to be random and too diverse to come from one simple static arrangement. It speaks of moving boundaries, shifting resonances, temporary instabilities, and repeated gravitational filtering over time. Neptune is not just sitting beside the evidence, it is written into it. Its present orbit marks the inner edge of the Kuiper belt, but its past motion seems to be written across the belt's structure more broadly.
Pluto's resonance is part of that writing. The Plutinos are part of it. The outer edge near the major resonances, the hot populations, the scattered disk, and likely even the delivery routes of some comets all point back toward Neptune's changing reach. What now looks like distance was once a zone of interaction. What now looks static was once in transition. The giant planets as a group make the picture even larger. Jupiter, Saturn, Uranus, and Neptune did not merely coexist beside a disk of small icy bodies. They exchanged momentum with it, and in doing so, they rewrote the solar system's outer structure. Neptune moved outward. Uranus was affected as well. Jupiter and Saturn influenced the deeper gravitational balance that may have triggered broader instability in the first place. The distant small body populations are therefore not separate from planetary history.
They are the distributed residue of it. The giant planets left signatures not only in their own present spacing, but in the orbits of countless minor worlds far beyond them. That is why the outer solar system should not be imagined as a quiet storage ground of leftovers. It is not preserving inventory. It is what remains after migration, scattering, trapping, depletion, and loss. The material out there is only a fraction of what likely once existed. and even that fraction has been sorted by orbital history. Some objects survived because resonance protected them. Some survived because they occupied less disturbed zones. So when we look beyond Neptune, we are not looking toward the place where the solar system becomes uneventful. We are looking at a cold archive whose pages were written in orbital mechanics.
Pluto's protected orbit, the resonant families, the excited disk, the Trojans, the missing mass, the bodies flung onto vast elongated paths. They all point in the same direction. The outer solar system only appears serene because time and distance have dimmed the motion that shaped it. What remains is not the untouched frontier of a finished system, but visible evidence that the solar system's far edge was rearranged by ancient violence, and only looks calm to anyone who arrived too late.
If you enjoyed this video, please consider subscribing. Thank you for watching, and thank you for being here. Your support genuinely means a lot, and it helps this channel continue exploring the universe one video at a time.